Hey all, welcome to the Riot Lunch and Learn series, the place where we spotlight Riot sponsors and partners. My name is Lauren Colatuno, and I'm the marketing director here at Riot. Just a quick reminders before we get started, this event is being recorded and will be posted to our YouTube channel and uploaded to the meetup page where you registered for this event. If you have any questions throughout the presentation, please just place them into the chat and we will get to the questions as soon as the presentation is over. All questions will be read out loud throughout the presentation. So whoever is watching the recording can also hear the questions. And please keep yourself muted throughout the event to help mitigate background noises. Today, we have Ryan Oddo and Courtney Robertson from Breadware to discuss the smart way to build smart products. Ryan, Courtney, I'm going to turn it over to you.
Thanks, Lauren.
Great, thanks. Let me share my screen.
Awesome. Hi, everybody. My name is Courtney Robertson. I'm with Breadware, and this is Ryan Oddo. Breadware, we are an industrial IoT product development company headquartered in Reno, Nevada. We build smart products for a wide variety of applications, but primarily industrial, utility-related sectors, industrial OEMs, things like that. We've done our fair share of smart building products, consumer products, wearables, things like that, and things to make things more efficient and have data-driven insights so that you can have a better business and provide more value to your customers. With that, I'm going to go ahead and turn this over to Ryan for the smart way to build smart products.
Awesome, thanks, Courtney. So, hi guys, I'm Ryan. I'm the product manager at Breadware. So let's jump in. So today we're talking about building smart products. So I wanted to start high level and just talk about what makes a great smart product. And so I've got a couple of examples here of products that I know pretty well. And the two things I want to highlight that you really want to pay attention to as you're building a smart product is, at the end of the day, it needs to be easy to use. The product that you're building probably has a not so smart predecessor. So it not only needs to be easy to use, it needs to be easier to use than that not so smart predecessor. And then the second part is it needs to provide long-term value to the customer. And this is especially key if you plan on charging a subscription with your product, because it makes it a lot easier if the customer feels that value every day. And then they're like, yeah, I don't mind paying the subscription. This is great. So jump into a couple of quick examples. So the first one is an occupancy detection sensor from a company called Coworker. Now, this isn't just a standard PIR sensor. This can actually count how many people are in the room. And it's got a lot of cool technology to be able to do that. So first off, it uses a high resolution thermal sensor to take an image of the room. Now, notice I didn't say camera at all. Camera is a bad word in the office environment. And so no one wants a camera pointed at them while they're working. So this is a high resolution image sensor, and it takes thermal images. So it's not an actual image. And then it does all the processing locally using this special AI chip that can do image recognition using very low power. And then the sensor just sends the number of people it sees over Bluetooth to a gateway, and then that gets sent to Coworker's software system. So from the end user's perspective, they just want the data and the software so that they can optimize their maintenance. And to be able to install these sensors, they just want to turn it on and screw it into the ceiling. And they don't want to change the batteries, very often. So with this, everything's done locally. It's battery powered. You change the battery every 5 or 6 years. Makes it really easy. So kind of back to our core principles. It's really easy to use. You turn it on and screw it into the ceiling. It's ready to go. And then long-term value. It's providing all this great data insight that then Coworker software can help business owners optimize their operations. So kind of, so the end user doesn't really care about all that technology built in. They just really want that number that's coming across Bluetooth. So then our second example is from a company called Stone Age. Now, Stone Age builds industrial cleaning equipment using water blasting technology. So these are really fancy pressure washers, basically. But they're purpose built to do very hard jobs that would otherwise take a really long time. And the one in the picture is designed to clean heat exchangers that are in processing plants or refineries. And the heat exchangers on the right, and it's a whole bunch of pipes that are about 20, 30 feet long. And the Stone Age tool has a bunch of water jets that, 4 or 5 jets, they're pointing all different directions. You feed it down the tube and it cleans the tube out. And this is the most time consuming part of the maintenance cycle for these processing plants. So it's very important. So the old way, the not so smart way to do this was, they would just attach the tool to the end of the hose and an operator would just feed it through each pipe. Now there's 80 or 90 pipes here, and those jets that are pointing in all different directions, they're strong enough to take your arm off. So if you pull the hose out all the way without turning it off first, then things get a little crazy. So in the interest of safety and efficiency improvements, Stone Age has been working on automating all their tools for quite a while now. So this one's called the Sentinel, and I'm not going to get into the layers and layers of technology here to make all this work, but it works really well. So because it's a robot, it's much more consistent than the guy feeding the hose down the pipe, and so it does a better job cleaning. It doesn't rush through the last 20 tubes because it's ready to go take a lunch break. It doesn't need to take lunch. So so they're able to see a 35% efficiency gain with the automated system over a manual system. And then kind of back to the whole taking people's arms off, with the automated system, the operator can be 30, 40 feet away. They're out of harm's way. Then they have a bunch of safety devices built in to keep everything in the heat exchanger. So it's a drastic improvement in safety. And then, while the Sentinel's operating, it's gathering data on every tube that it cleans. It stores that data. Then that all gets sent to the asset owner after they're done, and the asset owner can plug that into their predictive maintenance algorithms and use it to help improve their operations. And so this is a very complex product, but that's why I wanted to highlight it, because overall it's complex, but compared to its predecessor, it's very easy to use. So the operator just sits there, hits a joystick to move from tube to tube, and then the robot does the rest. And then it provides long-term value because it not only does a better job cleaning, but it also provides all this important data that helps the processing plants long-term. So, so that's pretty cool. And then the last one is a product called Bird Buddy. And as you can see, it's pretty straightforward. It's a battery-powered Wi-Fi camera that's mounted in a bird feeder. And I wanted to just kind of talk about a fun consumer product, and this was the first one that came to mind. So overall, Bird Buddy is pretty simple to set up and use. You enter your Wi-Fi credentials. You have to charge the battery once a month, and unless you spring for the solar-powered roof, and then depending on your usage, you probably don't have to charge it at all. And then value to the customer. When you want to take a break at work, you can log in and see what birds have been hanging out in your backyard. And then Bird Buddy's even got AI algorithms built in to be able to recognize what type of bird it is, and then give you all the information about the bird and kind of sounds it makes and all that stuff. So this is just a fun one, but I thought it was a good example of an easy to use product that then customers definitely feel the long-term value every time they log in. They're like, man, I'm glad I bought this product. So these sold out immediately. Last I checked, they're taking pre-orders for their next production run. But I hope this gives you an idea of kind of high level where you want to get to with your smart product, what some of the key aspects are. So let's jump into the build process. At Breadware, we've broken it down into 3 easy steps. We start in the discovery phase. So this is the planning phase. We gather requirements, we document success metrics, go over, deliverables. Okay, this is where we need to get to. Then we get into the pilot phase, or the build and test phase. So, it's important to add that testing part of it. You're not just building prototypes. You need to get them in the hands of customers, and gather important feedback. Do testing. So that's why we call it the pilot phase instead of just prototype phase or build phase. And then, once the product's built, ready to go, then you've got your operational rollout. Now this is, mostly in the hands of the company doing their full market launch, and then Breadware's there to help them ramp up production and, and then help optimize the product long term as you, get more feedback once it's in the field. So, getting into the details, I'm going to use a case study called about a smart plant watering system called Connected Plants to talk through the process. We're mostly going to focus on the discovery phase because that's the planning process, and that's where all the key decisions are made for the rest of the project. So, and spoiler alert, this is one of Breadware's demo systems. So we actually did build this, so it's based on a true story. But this isn't actually someone's product, so we're not giving away any trade secrets or any details. We do that because wanted to talk details about the project, and if we use an actual customer project, I'm not able to do that. So jumping into Connected Plants, the story starts with Joe. Joe's a commercial building owner, and he likes to have plants in the lobbies of his office, but he's having a hard time keeping them alive. He's been trying to have the cleaners water them, but they have, some of the staff are good at it, some of them aren't. And as they have changeover, all of a sudden he walks in and plants are dead, and it just doesn't look good. That's the first thing people see as they walk in the office, and he wants it to look the best. So this has happened several times to Joe now, and he really wants something different, So he'd love to have a system that waters the plants for him and lets him know if there's any issues. So most of us go to Google first and starts looking around, and there is some stuff out there, but it's usually either simple timer systems or very complex irrigation systems, more for like your backyard and things like that. So Joe, being very entrepreneurial, he sees an opportunity. He's like, well, I'm not, I doubt I'm the only one that has this problem. Maybe I should build this. So he does some more research to see if there's sensors to be able to detect, can I figure out the moisture level of the soil and anything else I might need. And he finds some maker projects where people have built this, and the sensors are available. He just hasn't seen anyone build it into a product that's fit for commercial environments. And so check that box. Product is feasible. So then he starts thinking through risks. He's like, okay, well, should I do this? So the biggest risk to him is, he's not a technical guy, he's a business guy. So he's like, I don't know if we can actually build a system that keeps plants alive. The maker guys said it worked pretty well, but I need to prove that out. And then the other one is, I want to buy this, but is anyone else buying this? Why are people not building this already? So those are the, big questions he has. So the next step, Joe starts talking to people. Like I said, he's a business guy. He wants to prove out, are people going to buy this first? Otherwise, he's not going to put any effort into it. So he starts talking to other building owners, as well as talking to some of his tenants to be like, hey, you guys have this problem too. And everyone who talks to is like, I totally need one of those. Like, do you have that built already? Can we try it? Like, so Joe gets really excited. And so he's like, oh, well, how am I going to fund all this? So he starts talking to investors, and they give him feedback. Okay, this is what we need. We need you to do a proof of concept system to prove out the market, start getting some traction. And then we also need a detailed, we need a development plan and a cost estimate. How much is this going to, cost to make? What's our full investment to get products on the market? And so Joe's like, okay, well, I can figure that out. First part was easy, getting people to sign up for the proof of concept system. He just went back and kind of picked the best applications. He's already got 5 buildings lined up. They each want 2 systems. So he's like, cool, I need 10 proof of concept systems. The hard part was finding someone to build it. So luckily he found Breadware, and we started talking to him and seeing what he needed. He's like, okay, so I need this, I need this cost estimate, development plan for my investors. We're like, oh yeah, perfect. We've got, a discovery, we can put you in a discovery program. It only takes a couple of weeks. We have you work with the engineers. They gather requirements, put together system architecture for both the pilot system and your production system. And then at the end, they're going to give you detailed cost estimates and pretty much everything you need to be able to hand to your investor and, know what it's going to take to build and launch the product. So he's like, oh, perfect, let's do it. So, so jumping into the discovery, first step is gathering requirements from Joe. So the engineers go through, they interview them, talk through everything. And I'm not going to go through the whole product requirements document with you, but these are the highlights of the key aspects of the requirements. So the core feature set, we need to measure the moisture level of the soil in the plant. And then obviously water the plant when it starts to dry out. That's pretty easy. We need to measure the water level in the storage tank, make sure we don't run out of water. And then we need to be able to send alerts to the users to let them know that there's an issue. Something like, water's getting low, your power's out, soil's getting dry, your plant's dying. So that's the software side. So for power, we want this wall powered. We don't want to be charging batteries, but we do want a battery backup just in case someone unplugs it to charge their cell phone or plug the vacuum in or something. You'd be surprised how often this happens, and send a service technician out to be like, oh, yeah, someone charged their cell phone there yesterday. Sorry about that. So if we have a couple days of battery backup, the system gets unplugged, we can still send a notification, say, hey, power's out. You've got a couple days, we're going to keep watering the plant, but someone needs to come plug this back in. Gives you enough time to go plug it back in. You don't have dead plants. On the wireless communication side, first obvious choice is Wi-Fi. But in a lot of buildings, getting on the Wi-Fi system can be more of a hassle than it's worth. And so Joe wants to include cellular as well and have that like the main connectivity. And then if they want to switch over to Wi-Fi, they can. So onboard sensors, we'll need the soil moisture sensor, the tank level sensor. For the communication interface, we want some LEDs on the product so that you can take a look at it, know that it's alive, but then everything else will be in the software user interface. On the mechanical side, the storage tank needs to hold at least 4 weeks worth of water. We don't want to be filling it up every week. That kind of defeats the purpose of having an automated system. Just got to water the tank instead of the plant. So at least 4 weeks worth of water. This is an indoor product, so IP64 enclosure should be just fine. Then overall, it needs to be aesthetically pleasing in an office environment. So we've got key requirements figured out. So let's start putting together system architecture. So we've started on the hardware side. We've got our plant. We've got our moisture sensor in the plant. Like I said, we're going to start with off-the-shelf moisture sensors. If those don't work with what we need, then we can look into designing one. But especially for the proof of concept, let's start with off-the-shelf. And then we've got a water tank that has the pump and the water line to be able to water the plant. We've got our level sensor in the water tank. And then we've got our AC power supply and our battery. And we've got, and then we're going to need a circuit board that handles all the intelligence to control everything, as well as sends data over the cellular Wi-Fi up to the cloud. So, so then once the data is in the cloud, we're going to need a couple user interfaces. Joe's mainly focused on the mobile app to start. But then, after talking to him, we think you'll probably need having a web portal could be nice too, because these are office workers. You get an email that there's an issue with the plant system. It'd be nice you're already on your computer. It's nice to just log into the web portal, check out what's going on. And then Joe's also going to need something behind the scenes to be able to manage all the users, add and delete accounts, as well as, gather usage analytics and, get all that important data that's going to help him, plan out new features and future products. So, so this is the overall plan. We still need to go through and actually select the technology that we're going to use, though. So we're going to start on the hardware side. Now Joe wants to build these proof of concept systems. So we need to find something that we can use off the shelf that we could build up really quick and prove out, that we can really water plants. Breadware's got a few options for this, and so the easiest solution would be to use our industrial controller. And the industrial controller uses the sliced COM board as a communication module. So it'd actually be using the combination of those. Now the industrial controller, to do everything that Joe wants to do right out of the box, just need to basically write your firmware algorithm, and it'd be ready to go. But it's probably overkill for this product. It'd be more geared towards, if Joe wanted to get into like the indoor farming space and be monitoring rows and rows of plants, and then the industrial controller would be a better fit. So Breadware's also got the slice board, which is a little smaller, a little more versatile, similar to the sliced COM board, but it has a built-in power supply. It's got an analog to digital converter, so it'll be able to just read the soil moisture sensors right off the bat. We don't need additional circuitry, and it's got the battery charger built in, so we have the battery backup. So it's kind of that nice mix of connectivity and then just enough to provide that compact controller for a system like this. So for the proof of concept, we can just wire everything right into the slice board, and then for the production system, I'll show you in a couple slides. But we'll do we will add a custom circuit board that'll make things more production ready. So that's the hardware side. On the software side, when Joe started talking to us, he's like, so main thing I need is a mobile app, and I'm probably just gonna need like an AWS backend to go with it. And we're like, okay, well, we can quote that with you, but if you're interested, we've also got this Rise software platform that's custom built for OEMs like yourself, and we have some templates that would actually fit your application really well. So instead of putting all the work into building up the infrastructure in AWS, we've basically done that for you. We can just white label the system and have it ready to go very quickly. He's like, oh, well, that's cool, but do you have a mobile app? And we're like, yeah, we've got mobile app that that basically mirrors the end user interface, and it's a native app that that the user would download from the App Store, from either Android or iOS app stores. So he's like, oh, so we do a demo with the software platform, and he's really impressed. He's like, wow, that's really like 90% of what I need. We just need to change some names, put some pictures in, and and we're ready to go. This will be great for proof of concept. I've got some more stuff that I want for production. We're like, yeah, that's easy. That's the whole idea, is we can start simple. We get your logo in there. We get people using it, and then we get that feedback before we put too much time into customizations. And then but we still have time before production to customize it the way you want. So, and like I said, this is a demo system for Breadware, so we do have this built out already. So here's a couple screenshots of the login page with our connected plants logo in there, and then our devices page, and you can see Joe's plant over here, and then the plant that's in our lab. So that's pretty fun. So okay, so that's our technology selection. So back to our block diagrams. So we're going to build kind of two different versions here. We'll go through proof of concept first, then I'll go through the production system. So like I said, for proof of concept, we're going to start with the slice board. And the main goal here is, one, validate sensors and our watering algorithm that we're going to write in firmware. Make sure we don't kill the plant, and that's pretty important. And then we also want to gather user feedback, and and I can tell you from doing demos with this system, every time I show it to them, someone's got an idea of what to add. Oh, can you measure humidity? Can you pull in weather data and all kinds of different stuff? People have great ideas, and so so Joe will get all kinds of great feedback from the proof of concept. And if you notice, these are validating those key risks that Joe came up with when he started outlining the business. And so this will give Joe confidence, and will give his investors confidence to put the money into the full production system. On the software side, we're just going to roll out the web app, the web portal to start. And that's because we're going to pre-provision the systems for the users. We're not going to make them set them up. That's a kind of, we want them using it, but we want to make things as easy as possible. And we want to be able to build this up in a couple of weeks. And so it takes time to have to roll out the mobile app to the App Store, and then the end users have to download it. And then every time we make changes, they have to update it. So it's easier to just start with the web portal, and then we add the mobile app when we get to the production system. So speaking of production system, here we go. So for the production system, on the mechanical side, we're going to build a custom enclosure that incorporates both the water tank and the electronics enclosure into one device that blends in the office. So it just looks like another piece of office furniture sitting next to your plant, but it happens to have a hose coming out of it and a couple wires. So most people wouldn't even notice it. But that's key to that to the product. On the electrical side, we're going to design a pretty simple custom circuit board for the slice board to plug into. And that's going to get rid of all those wires that we had in the proof of concept. So we'll have nice connectors coming out the side of the enclosure for the moisture sensor to plug into, and then the pumps can be pre-wired. And this will make this a lot easier to build, in a production environment, and and just a lot more reliable. So still a pretty quick build process, because all the intelligence is going to stay on the slice board, and we've already built most of that in the proof of concept. So so then on the software side, like I talked about, this is when we start rolling out the mobile app, and we really need to think about the onboarding process. So the mobile app already has a way to be able to scan a barcode on the device, and then it automatically allocates that device to your account. And then basically after that, we would add a couple of tutorial screens that would walk the end customer through the installation process. So, things like this is where to put the moisture sensor. This is how to plug in the hoses for, to the tank. And then on the software side, this is where you need to configure is, how much water does your plant need? Does it like a little water, a lot of water, things like that, and you could do that in a couple, easy steps, but back to that high level of making the product easy to use, if you nail that that provisioning process, like you're 90% there. Because once this is set up, then it's just watering your plants. People, the only time people are going to look at it is if they get an alert that there's an issue. And so then that's the second part of easy to use. When they do get that alert, they need to get to the information they need as quickly as possible. So we just want to make sure that we go through that workflow and tailor the software so it doesn't take 10 steps to get to the information you need. Basically, just to know that the water is level, or someone unplugged the system so that they could charge their cell phone, things like that. Usually the alert itself will tell them that, but then if they want, they may have to go look at the dashboard and kind of see what's going on with the system. So that's the engineering part of the production system. So like I said, we need to give Joe a full project plan. So we've already talked through the proof of concept build. We talked through building the production design. Once those beta prototypes from the production design are ready, then we go into field testing. So we did some testing with the proof of concept, but we want to make sure the production product is ready before we start spending a lot of money ramping up production. And more importantly, we don't want to do any certification testing until we've gone through durability testing, because we don't want to redo the certification testing. So we get those beta prototypes to Joe. He gets them out in the field. He tries to abuse them as much as possible. He kicks it over, has his dog lick it, whatever, spill some coffee on it, whatever you can think of. We give him a few weeks to do that. Once he's comfortable with it, we're not going to, and we don't think we're going to make any more changes, we jump into certification testing. So since we use the slice board, it takes a lot of the stress out of the certification testing. There's two main things that need to be tested in this product. We need to go through basic FCC certification. So that's the FCC, any product that has a radio in it, the FCC wants to scan it and make sure it's not going to cause interference on other radios. And then the other one is cellular carrier testing, and this is going to be dependent on the cellular carrier. So like I said, with the slice board, it takes a lot of stress out. So with FCC, the slice board uses pre-certified communication modules. And so that really reduces the amount of testing that you have to do, because basically pre-certified means FCC's already tested these and knows they work. So then we just have to do a final scan to make sure that we didn't mess anything up in the final product. And then the other area to be concerned about is the power supply. Power supplies can be noisy and they can cause their own emissions issues. So with the slice board, we do have a custom power supply on there, but we've already gone through the whole FCC scanning to make sure that everything's going to pass. So it's really just a formality by the time we build it into the final product. And then it's very similar on the cellular side. We're using pre-certified cellular modules. So there's really not a concern there. The cellular carrier testing was designed for cell phones, and in cell phones, they're writing everything from scratch, and it's a lot more involved. Now, the cost can vary quite a bit with cellular testing, depending on what provider Joe wants to go with. If he wants to go with Verizon, it might be pretty expensive. If he wants to go with someone like T-Mobile, they're usually willing to actually test it for you, and so it just takes some time. So that does vary quite a bit. so that wraps up. So, okay, product, we've got our production product, it's certified, ready to ramp up production. So this is the fun part. We get to like sell things and people get to start using it. So, so like I said, we're going to start ramping up production. We're buying parts, we're cutting tools for the custom housing, getting everything ready to go. While we're, while we're working with contract manufacturers to get that all set up, Joe's working on a sales and marketing plan, and he's getting the word out and getting these ready to sell, so that when they start rolling off the production line, he's got buyers already lined up. So then after launch, like I said, there's still work to be done. It's a lot less effort than that full build. But there's always little software updates that you want to be doing. Sometimes you find a firmware bug that, and then we need to push a firmware update through the software. And then, like I talked about, there's all kinds of analytics that you're gathering off of your smart product because it's so smart. And then that helps you plan out the next, either your next round of software updates or your next, whole product line that you might want to add to it. Maybe, if this does go really well, Joe wants to jump into the like indoor farming market or something similar. So, or something else in the office, smart office environment. So, so that's the optimize and expand. So to wrap this up, we put together kind of three things to keep in mind, and as you're going through this process, and mainly as you're like planning early on. So first one is fail quickly. Identify what aspects of the product are the highest risk, and address those areas first. So just let Joe put together his risk assessment. He's like, are people going to buy this? And, am I going to build, is the technology there to be able to make it work? Like, that's what you want to do up front, so that, and then figure out how to test that as quick as possible. So that's where some of that, using off the shelf parts to get proof of concepts out there, get some testing, can be really important. So then the second one is be resourceful. So, not everything has to be custom. Try to use as many existing tools, products, and frameworks to accelerate the development as possible. This isn't nearly as hard as it was 10 years ago. Trust me, I was there. It was hard, but everything was custom back then. Now, like I did just show you, you can build a full proof of concept system in a couple of weeks, get it out watering plants, or whatever you need to do. So it's really an exciting time to build smart products because of all the resources available. And then kind of along those same lines, ask for help. Don't try to hire everything internally. And this is true for big companies and small companies. So our recommendation is always decide what you want to be good at and focus on that, and then bring in other partners that help you fill in the gaps. So there's a lot of different disciplines that it takes to build these smart products, and trying to hire all those resources internally, and the chances of actually finding the right person that knows how to build every aspect that you want it's a huge challenge. So so it is okay to bring in outside firms, and it helps you move a lot quicker and a lot more efficient. So that can be very helpful too. So that wraps us up for today. We wanted to leave enough time for questions, and so Courtney, how are we looking on the questions?
Yeah, good. I got a few through the chat for you. I will kick this one off. This was in regards to the Rise software platform. They wanted to know how much customization is available for displaying data on a website.
That's a good question. And the answer is, as much as you want. um,
Good answer.
So yeah. So to go into a little more details, so so with the Rise software platform, we have our pre-built templates, but then we have access to the actual code for each of those pages in the template. And so it's very easy to go in and add new graphics and new tools to basically do whatever you want. And so and we help you with that process. So it really it's highly customizable and can kind of fit whatever your needs are. You're not limited to what we have in our drag and drop library, basically. So
awesome. And then yeah, I mean, it's there if you want it for convenience, but otherwise build it to exactly what you want. All right, this next question also was related to Rise. Are my customers the ones paying to access your software platform, or is that something I would pay for and then grant them access to?
That's another good question. So it's the latter. So you would be paying Breadware for the subscription, and then you have the ability. So we have a subscription portal in the end user portal. And the way it works, we have you sign up for a Stripe account. That way all the funds go straight to your account. We link that Stripe account to the subscription page, and the end user can go in, put their payment information in for your to pay your subscription, and then the software handles everything from there. So there is a little bit of customization for us to to put in pricing options, and kind of everyone's got a little different subscription model, but all the framework's there. And so basically we can handle both. So.
Awesome. And just one last question about the Rise platform is how can we get a demo for the different software options?
Sure. That one's easy. Just
that's easy.
Reach out to out to Courtney or myself, and we'll set up a demo. If you go to breadware.com, there's a we have a Calendly calendar, so you can go in and actually just pick out a time that works well for you. And probably not going to have Courtney on the call. You're going to probably have myself, and then our head of sales, Clayton, will be on there too. We can go through the demo with you and talk through how it applies to your product. So I can stop sharing my screen.
If you request me, I might be able to join, but I'm
right,
just kidding.
Right.
I'm kidding. All right, one other question. Does Breadware do all the work, or do we partner with other development firms?
So it depends on what work we need to do. So kind of back to know what you're good at. So we do partner with other firms for mechanical and industrial design. We do all of our software development in-house. We do our electrical and firmware development in-house. And then we do have partners for contract manufacturing as well. And so when you get to that manufacturing stage, we can help manage things with the contract manufacturers, but we don't actually build it ourselves. So.
Awesome. Well, Ryan, that is all I have. I'll give everyone maybe another second or so, just in case they do have another question they want to drop in the chat. Oh, we got one more. Is the SliceBoard FCC and carrier certified?
So on its own, the SliceBoard is not. It's all, we've gone through pre-scans, like I talked about earlier, to be able to give confidence going through the final testing, but we can't, FCC won't certify the entire SliceBoard as a module. And so when you design the SliceBoard into your product, we would need to recertify anyways. So there really wasn't a value to getting an FCC certification for the SliceBoard itself, if that makes sense. It will be pretty easy. It's about $3,000 to $5,000 for FCC testing once it's built into your product. And like I said, we're very confident that it'll pass. So Then on the carrier side, it's very specific to your carrier. So we haven't done, and it's very dependent on the cellular antenna that you use. And so we have the equipment to help you work through carrier certifications, and our project managers know all the details about what you need to pass. But again, it's kind of once you need to build the slice board into your product first, and then address carrier certifications from there. So
thank you. All right. Well, everyone, again, our website is breadware.com. If you have any other questions, feel free to reach out, and definitely connect with us on LinkedIn and follow us on all major platforms to stay updated. So we really appreciate your time today.
thanks, everyone.
Thank you so much, Ryan and Courtney. That was a great presentation. We appreciate you all being here. Just a reminder, we do these lunch and learns on Wednesdays at 1 p.m. every week Eastern time, and we hope to see y'all again.
Thanks, Lauren.
Thank you.
Thanks, Lauren. Hi, everyone.
Bye.